Oh, fantastic. Okay, good, good. And I'm going to make sure that I can share as well then my other screen should be, and just want to verify, would you be able to see that screen as well, folks?
Yes.
Okay, great, good, good. I was a little worried about that. Okay, good. So I'll begin over here. And then as I sent out to people, and this is the website, the main website for the workshop today. So if you get lost, come back to this site and you should be able to make your way back. Here, if you go to that website, you'll be able to see a link to where there are a couple of zip files. And one of the zip files is for Windows 10 users, and then the other is for all of the rest, so Mac, Linux, or Unix. So, and then when you open that up, if you're able to follow along today, then you'll see two versions. One is what I call the working version, where if you open it up, the files that are produced by the programs are not in there. But if you just want to listen and listen along, you could open up number 2, where it's got complete, and it's the same exact files, but like if it produces an Excel spreadsheet, then a particular program in there, then it'll already be there for you. So it's just kind of two perspectives on the same sort of information there, so you can follow along. Sometimes people just like to read through, and that's a great idea. And one thing just to point out as we're learning a program language here too, is that I heard something very interesting. I was watching a class on Python programming in Udemy, and one of the first things that the programmer emphasized, or the teacher emphasized, was that most programming code is read by people rather than written by people. So meaning when you write programming code, I'm a big advocate of writing it in a way such that my rule is, if I come back to something a year from now, if I can't read it and understand it very readily, then I probably haven't written very good code. And that comes from a lot of experience on my own part, where I tried to write optimally simple and very short code, to the extent that I confused myself when I picked up that programming code, like a year later. So that's why I also give you two versions there, so that you can look at it. And I'm going to try to emphasize that today as well, keeping in mind that most code is read even by yourself rather than written. You kind of write it once and then you come back to it. So those are really sort of important points to keep in mind. The other thing that I asked people to, if you want to download, that I'm going to use is something called Anaconda. And Anaconda is a play on words because it is a development environment. You'll see the word you'll see the term IDE, Integrated Development Environment, for Python. So, and it's absolutely free. And the reason why I use it, and I recommend it for people doing corpus research, is that it includes a couple of things. It has a lot of extra packages that don't come standard with Python. One called the Natural Language Toolkit, and the Natural Language Toolkit is exactly what it says. It provides a bunch of tools for working with, for natural language goals, okay? So it makes things like tokenization and even tagging makes it quite easy to do. So, and it's free, and it's included with Anaconda, which is free as well. So, and if you, and I'll be talking about it here today, and there is a actual free book online provided by Natural Language Toolkit people that you can sort of follow along and teach yourself how to use it. So that's one thing that is that I really enjoy. And so I'm going to leave that at that for right now, and I'm going to come back, and I'm going to head back over to Spyder here. So just to verify, then I'll take Tony's cue here that you guys are able to see that, right?
Yes.
Awesome. Okay, great. So and I am in Spyder. I started that by opening up Anaconda, and then there's a sort of a box there to select Spyder. And Spyder is an IDE, an integrated development environment for Python. What I've done is that I have loaded the I unzipped the zip file, and then I've loaded the first portion of the presentation here called tokenization. And tokenization is basically taking all the words of a corpus and then separating them out and then doing things with them. So I've got a number of different files here that we are going to work with. And what I'm going to do is at first I'll go what may seem a little slow with some basic ideas, but then we'll be able to see how those ideas sort of, as we say, snowball, or they accumulate. They build one on top of each other. So I'm going to start with this file number 1 here, and let me just talk about the anatomy of of this environment here. I should. So when you start up Spyder within Anaconda, you have 3 main windows here. You have your files over here. Are you able to see my mouse as it moves around as well?
Yes.
Good. Okay, fantastic. So over here to the top right then is where your list of files are. And you want to make sure that up here that you've sort of selected the file, the folder where that's called 01 tokenization. And then your different files will appear here. And then if you click on the file and you double click it, then it'll appear over here and you can edit the file. Down here is where your output comes. So, and you can also actually just practice with different variables and then spit them out again, and it'll tell you what it is. And I could go, okay, well then let's let A be equal to A plus 2, and then now A is equal to 3, etc. So it's a really nice environment where you can edit files over here, and I can run these files as well. I can also do some calculations over here. If I want to open up a different sort of calculation area, I can do that over here, starting up a new console. So at any rate, and then what's really nice too is if you look over here at the top right, not only does it list your files, but it also will list any variables that you have. And that for me is crucial because, you know, in theory, in fantasy, you can write a program and then say, great, it's going to work. But really, it's building information in piecemeal, you know, little by little as you move along. So as you can see, already this variable A is written up here, and then it's telling me what its value is. I'm going to talk a little bit about the anatomy of a Python file then. And what you get is at the very top, you get these, people tend to what's called import different modules. And a module basically is a library of programs that, that have a particular function. So, and the reason why you import these, if it seems like, well, why doesn't Python just import them automatically, is that it's all about saving memory. computer programming, especially in my experience, corpus research really taxes even the best computers today in terms of the amount of memory that they require. So what you get is you get some imports up here, and one is over here on line 5 where I import the natural language toolkit, so that's already, I can use that now. And then also there's one here called helpers that is in that directory, that is just some helpers that I wrote that will save us some time. They're very simple, so if you have time to go back and look at those later, you just go ahead. I do want to point out one other thing here, and that is what's really cool about this spider environment is that you don't just have to run a file, the whole thing, and then hope for the best. You actually can select portions of this file, only in Spider. And then if you see this black button right here, what that does is it runs the selection of your file. So you actually can build this in even more step-by-step manner, piecemeal fashion. So I'll just click that right there, and then this file path variable will be assigned, okay? And it also, when it went to the helpers, it brought in a couple of things here as well. But now you can see my file path variable is now referring to that value right there, which is just one little text in my corpus. So why am I doing this so small? What we're going to do first is we're going to work with some basics of Python with a single text file. And then after that, in half an hour or so, maybe 45 minutes or so, we'll then start to look at how you start looking across a whole corpus of files, because I completely understand. No one works with one text file. But my goal here for this first part is to show you what are some of the basics of Python, and just limit ourselves to not having to deal with both bringing in a whole bunch of files, storing that data, and looking at the basics of how Python works. So, okay. So what we're going to do then is that I've got this file path right there, and what it's going to do is it's going to read into this variable called text the text that's in that file. So I'm going to select that again, you see, and I'm going to select the black part there and just make sure that everything is running. I'm going to check here. Are you able to see that call out window as well, folks? Yeah?
Yeah.
Good, fantastic. So this little call out window then, this is some data from a corpus that Randy Reppin had put together for American English. And I've organized it like this because in a lot of corpus research, people tend to put headers at the beginning of files. And those are basically just information about that file, right? I mean, if you're doing sort of statistical research on this or analytics on it, they're basically independent variables, right? So this is a file right here that I want to analyze. And it's a file that's got, and I just put in really basic information. I mean, I could have put in things about the gender of the person, when it was written, what the purpose was, whatever, a whole bunch of information. But I don't want to analyze that at this point, okay? I actually want to work with this file and ignore these headers for right now. So, and then I also want to, as a goal, separate the tag here from the actual token, right? So how do I do that? Well, what I've done in this helper files is I've written it so that you can read in that text, and then you can put into what's called a list here, the particular headers that you want to get rid of, and then it'll give me that text, okay? So what is a list? Well, let me give you an example here. A list is basically, I'm going to go over to a different console window here, And a list is Python's term for an array. So here's just some numbers there, right? It's an array, but Python calls it a list. You can access those lists by indexing, right? So if I want to get 0, right? The zeroth, the first item of that list, then I use a 0 there. If I want to get the second item of the list, then I use 1. Oops. And then that prints that out for me, right? So as you can see, it's a list that's got 4 items. I can get the length of it, just like that. And I can, so they're called 0 indexes because the very first item is a 0. So then this is going to be place number 3. All right, and that's pretty standard in programming languages, to tell you the truth, to have what's called a zero indexed array, okay? But they call them lists, and these are our bread and butter in terms of Python. Great, so what am I going to do now? So I'm going to filter that with this little thing I wrote, and now as you can see, it's given me that same text back, but without all of the headers in there. And so I can just focus in just on the data there. Great, okay. Now, why did I bring in this NLTK library, okay? Well, what I can do with that is in this routine called word tokenize, it takes that text and it breaks up every single word on a separate line into a long list. So if I select this, like that, then I can run that, okay? Or if I wanted to, I could go up to the green item here and I could just run the whole thing, okay? Then I get this particular variable right here, tag tokens, and it gives me each of the tokens there in that file as a separate item in that list. Okay. All right. So no big deal, right? I do have a list here though. This is size. It's got 1,663 items in there. All right. That's not very helpful, to tell you the truth. It's just it tells us how to get to separating those things out, those words out, so we can work with them. I'm now going to open up number 2 here. And in number 2, I'm going to clear up my variables. Okay. And I've got the text here repeated for you. Okay. So I'm going to run it all the way down to here, down to get the tokens. Got the same data here. Okay. But what I want to do now is I want to take the word learn or politics or while, and I want to separate out into one list all of the tokens, and then into another list all of the tags for them. So what we have to do here is talk about another basic of Python. And I'm going to clear this out. And we talked about lists. So I'm going to bring back this one. I've got that list there. Okay. And here's what happens with lists, is that with a list, sometimes you want to take that list, like we're doing with these tokens, and you want to separate things out, and you want to do things with them. Okay. Well, there's an old way of doing this in programming, right? And it can be done like this. Let's have a look at this really quick. Is that you can create a new list and make it empty, okay? And then you can loop through that list, the original list, this ls here, and then you can do something with each variable there. So what this says is, take each element in that list, 1, 3, 5, 7, okay, and I'm going to do something with it, and I'm going to call that element I, okay. And so what I want to do is that I want to take that element I, and I want to add 100 to it, just for fun, okay. And then after that, once I've created a new variable called x, added 100 to it, then I'm going to throw it in to this new list, okay, by this little procedure called append, okay. And that'll work just fine if I do that, okay. So now you can see I've got ls2, the second version, and it's taken each of those 1, 3, 5, 7, and then added 100 to it, okay. Well, that is that works. The problem with it is, and the challenge for corpus linguistics is that you're dealing with sometimes millions of words, thousands of words in your analysis. And the problem with this is that what you have to do is you're basically taking every single one of these items here, 1, 3, 5, 7, and you're doubling the amount of memory that you're taking up on your computer. And if you're dealing with a text file that's got 2,000, 4,000 words, you can really start to tax your computer's memory, okay, your RAM, basically. And especially for languages that don't involve English, so they involve, languages that use non-English, non-ASCII characters. This can be especially taxing for your memory. So this accomplishes the task, looping through like this, but it is not the way people program in Python nowadays. Just let's put it that way, okay? You can, if you want to, but you can run into some significant memory challenges. So then what's the better way of doing this? Let me paste in something here for you. Notice here on this line, I've got the 4i in ls right there, okay? It's right there, still there, okay? But on this other side here, I've got that I, that same guy right there, that I, and I'm gonna add 100 to it, okay? And so I'm looping through each element in I, in ls, I'm sorry, that list. And to each element, I'm adding 100 to it. And then I'm basically going to end up with that list changed. That's a much more efficient use of memory, okay? And it's called list comprehension. And basically what it does is, instead of copying each of these elements, 1, 3, 5, and 7, to a new place in RAM, okay, into your computer's memory, or even on your disk. It just depends on how stressed out, how much data you're processing on your computer. Instead of doing that, what it's doing is that this operation here replaces this 1 with 101. It doesn't create a new version of it. And it's extremely efficient in terms of processing. So basically, I'm going to take this ls now, and it's going to change it. You can watch up here after I run this, and it'll change this to 101, 103, 105, 107. So that's a lot more efficient. Now, let's go back to our data then. Okay. And with our data, we can do the old way, okay? What we can do with this is we've got our tokens and our tags. We want to separate them out into one list that's got all the tokens and one list that's got all the tags. Okay. And so I can create this sort of temporary new one here. Okay. Create a new list. And again, this is not the way we want to do this nowadays. Okay. I create this empty list, and I'm going to go through each one of these tokens here that are in this list right here. Right. I'm going to go through each one of these guys, okay, and I'm going to do some operation on that token, okay. Now, what does this do right here, okay? this NLT tag string to tuple. Well, let me show you. Let's take maybe this word right here. Okay, and I will make it easier for you to conceptualize this. Copy that. And what I'll do is I'll just write in here one of those up there. So learn is the word, and then it's a noun. Apparently, although I think that's a verb. But, you know, tagging is not a perfect process. And what that produced was called a tuple. And the tuple is basically a type of list, okay? And it's actually more memory efficient than a list, okay? And we can talk about that later if you wanted to. But basically, it's a type of list, a memory efficient type, but you can still get at it. So for instance, if I were to go, let's let A, B, that right there, I can get at each of those by saying A, oh, that's going to be the token, and then A1 is going to be the tag, okay? So what it does then is that it produces a list, a tuple of 2 items, and what we're doing over here is that we're going to throw each of these into this new list that we're making, okay? So what is that going to look like? Well, let me run it. Okay. And so we should have in this particular variable now a list of lists, right? Each of these has, so we've got core, and we've got N, that's a noun, which is the determiner, et cetera, et cetera. Great, okay. So that's fine, but that can become very memory intensive over time, especially if you have a very large corpus. So what I'm going to do now is I'm going to get rid of that. And I can remove that variable there. And I can do this list comprehension and accomplish the same thing, okay? So what I can do is I've got my for token, right there. And that's the same thing as written right there, okay? And then I can do that operation on it. So it's taken token and it's working on it right before the word for, okay? And as a matter of fact, what's interesting about Python is that I can actually separate these out onto separate lines so that I can read them a year from now a little better. And this may look like the same number of lines, but it's extremely efficient. So I will select that, and then I'll hit the black thing arrow here, and now it's give me this list, that same list. So we're getting there. All right, now I'll save that, and I'll go up to number 3 here, okay? So now I've got the same data here. I'm gonna clear that out just to start all over again with this. And what I wanna do is I want to get rid of the punctuation in all of this, okay? Because I want to do some analyses on the words. So my goal in this particular analysis is to get rid of the punctuation. So I could do this the old way, all right, by creating a new list, and then I can go through and I can look to see whether any one of the tokens in there is in my punctuation list. And if it's not, then I can append it to this new list right there, okay? So where did this come from? This punctuation list is right here, and it came in from that helper file that I wrote for you, okay? And so I just basically came up with a little list here that shows what the punctuation, different punctuation that I'm concerned with in English, okay? And so I could do it this way, but I actually think this is much easier to read, where I'm going to go through, I'm going to loop through the tags in the tokens list again, right? And then after this, looping through, I'm going to say, basically I'm saying here is keep I, right? If the first element in I is not in the punctuation list. So what does that mean? So I'm going through here, or it's looping through each one of these, and it's saying, I0. Well, if the first one in each of those tuples is in that punctuation list, then don't give it back to me, okay? So I'm basically going to reduce this list to give me only words. I can run this, and now watch this number here, 1663, will be reduced because it's going to get rid of all the punctuation. And so now we're down to 1,297. Right there, right? So it's going down, and looks like there's still some problems because it's still giving me ones that, it's still keeping ones that have nothing in them, basically, that they're zero length strings. So, but we can deal with that. All right. So there's that. I'll be able to then get these tags and these tokens separated into individual lists, the word and the token, and I'm also able to get rid of the punctuation. I'm going to move on now to the fourth file here. Right. And I will, again, I'm going to remove all my variables just to start all this up. So what can we do here again? I'm going to run this one more time, all the way down to here, and down to line number 19 is basically what we did in all of file number 3. So let me run that. Still running, that's good. Now, let's take that same idea, right? Where I said, I'll break this down into different lines for you here. Okay. Like that. And so again, I've said, let's go through all those tags and tokens. And if the first element, right, the word, the token element, is not in the punctuation list, okay, then give it back to me so that I can reduce that, all right? So now, but we did notice here before that you still got these zero length strings for some reason. So I don't want those to mess up my calculations. And I'm going to do the same thing with this list comprehension right here. So again, I want to be able to read this a year from now. So I'm going to write that, I'm going to break that up. What am I going to do now? Well, it's the same logic here. Okay, I'm still going through whatever's left over from these tokens and tags, okay, of my 1,297 items. And I'm going to get rid of, let me put that up here so you can see this. Okay. I'm going to say, look, if this is zero length, meaning that it's equal to nothing, and that's that first part of that list right there, or if for some reason my programming screwed up and the item none came up, and none in Python is just basically a way of saying a null value, okay? And so meaning that it's pointing to nothing. That can't happen. Then I want to get rid of those. But essentially what this will do is it'll get rid of all those tokens that are zero length, okay? So I can run that. And again, by doing this list comprehension, I'm going to end up reducing this variable right here. So this 1297 should go down after I select that area, and I go up here. Yeah, and we reduce it a little bit more. And now when I open it, it should, and I just double click it for this one file right here. I'm basically got only words and tags. Great. Now, what I want to do though is that I want to do some work just on the words, just on the tokens, and then maybe a little bit later we'll do some work on just the tags. Okay. So what am I going to do now? I want to put all the words, all the tokens, I'm sorry, into one list, and then I'll want to put all the tags into another list. And the great thing about Python is that if you put it into a list is actually ordered in the sense that if I create a new list, I can be assured that in that new list, the item 0 refers to learn, and the item 0 in the second list refers to its corresponding tag. Okay. So what am I doing here? Well, I'm going through that list right there, and I'm looping through all of them, and I'm saying in the 0 position, right, of these little tuples that it produces, mini lists, okay, give me that back. That's why I'm referring to I and then sub element 0 here, okay. And if you notice here too, I'm going to do the same thing for the tags. And I'm going to separate out item number 1. So 1 is the second item in all of those. And so basically what these two routines are going to do is they're going to give me a list that has all the tokens and then another list that's got all the tags. So let me close that up. Wonderful. Now I can open up the tokens variable here. And you can see that it only has words. And it doesn't have any punctuation or 0 length strings, okay? And then if I open up the tags, double click on that, and now it's got only my tags in there in the same order, so they're not out of order. All right, so let's do an analysis here, okay? And what I want to do is I want to, for this is why we've been working with one file, okay? Just this one file here. I'm going to show you how you can do an analysis on that real quickly. And I want to get the type token ratio, okay? I guess I should point out something here for you guys that is a programming tendency of my own that not everyone uses. So as Tony told you, I'm a professor of Spanish and Portuguese. And Spanish, Romance languages are highly inflected, meaning that they have a lot of morphology at the end of words to sort of remind you of what a word is. So for instance, if a word is feminine, with a lot of words, you'll get a reminder of the word that is feminine. Okay, so the word for girl, for instance, will not only be the word for girl, but it also say, oh, by the way, she's female. Okay, so at any rate, I like to do that in my programming as well, with that idea in mind that I want to be able to pick this up a year from now and know what those and know what that code is doing. Okay, so here, when I create a variable for myself, probably I should do it over here, my variable list, okay? I like to put at the end of my variable names a little reminder of what type of variable I'm working with here. So here, for instance, this tags, tokens and tags, tuple ls. What that says to me, and this is my only convention, my way of doing things, and no one else that I know of really, is that it says, okay, I've got a list here, okay, and so it reminds me, that's true, I've got a list here, and it's got a list of tuples inside of it. So that's why I remind myself, oh, when I read this a year from now, I can say to myself, oh yeah, so that's going to be a whole list of things. I don't know how long it's going to be. And each of those items in that list is what we call a tuple, okay? So this one here, in terms of tokens, I know that I've got some words that are probably tokens, and I also know that it's a list of tokens. It's not just a string, okay? And for my own writing, you know, maybe if I had something like this, tokens S, then that says to me that it's a string. So, and so maybe, you know, it was just in a string, and I would be able to remind it of that, that it's in a string. So why do I do that? Or why did I go into that? Here, for instance, I put an F here, and that's going to remind me a year from now that this variable here is a float, okay? And a floating value is basically one that has a decimal. It's your basic decimal value, okay? There are things called doubles as well, but this is basically a floating value, okay? So how do I get the type token ratio out of one line, okay? Well, if you take this tokens right there, okay, and there's my tokens variable, right? It's got right there. I can find the list. I'm sorry, I can find the length of that, okay, in Python by wrapping that variable with that right there, and that'll give me back, that'll return the how many items there are in that list. So now I know it's 1050. So I can use that. Now, type token ratio though, right, uses well, there's a lot of ways to calculate it, but one way is to calculate it as the number of unique items, okay, in a text over the total number of tokens, right? So what is the set thing then, right? Well, the set thing is this. If I had a, let me see if I already have one made up for you here. Trying to be efficient. Okay. So what I've got here is that I can do this. If I had a list like this, and I had some repeating items in there, okay, there. So that's my list now. I've got that, and you can see that I've got one that's repeated 3, 4, 5, 6, 7. I want to be able to produce something that'll tell me what are the unique items in here, okay? And then get the length of that. Well, in Python, if you wrap something with set, okay, then it'll actually give you back the unique items in that. And then if I take that one step further and I wrap that with length, and it tells me how many unique items there are in there, okay? So I could do this for this right here, and then go. And that's basically for this small little list here, short little list I gave you, it'll tell me the type token ratio of that, because it's taken the unique items and then dividing it by the number of items in there, and then you get that right there. So I can do that also for this tokens right here, okay, and it can tell me what the type token ratio is of that particular text. And let me see if it got it out here. And there it is. So the type token ratio of that text is 0.43. So that sounds right. All right. Yes, I will get onto the lambda part when I get onto, so I see there's a question that when lambda is used in Python code, we'll use that. I'll show you how to do that when we get to talking about pandas. All right, good. So let me close that up. Oops, I'm sorry. All right, good. I'm going to move on now to number 5. And we're good. Let me get rid of all the variables so we can start all over again. Good. Now, so this code here, number 5, then basically does everything that we did in number 4 up to line 25 if you're following along. So I'll run that. I know it's a little redundant. We've got all of our variables back here again. And you can actually clear this console here if you want to by hitting Command and then L, and it gets rid of it. So if you like to have a clean environment. Now, this might seem really ridiculous to some of you, but what it's doing, ridiculously simple. But remember, this is the intro course on Python, so you got to learn the syntax of Python. What I've got right here are what are called functions. And functions are basically just isolated pieces of code or calculations that you can use, that you can reuse, you can use over and over and over again. And we'll see that that becomes a huge advantage as we start working with multiple files here. So what I've done here is I've written a function here that basically tells me how many words there are in a particular list. Now, you might be saying, well, why? That looks like even more lines than you did before. And it is, but it's to teach you about the syntax of how a function works, and then actually what happens when you do this. So what's going to happen is, if I were to, so I've got this right here, and actually I'm going to add a line here, and I'm going to run this function on this list here called tokens. Okay, and so let me just say, let x be equal to count words, and then I'm going to hand over to it. And the term in programming is we're going to pass that variable. Okay, I'm going to pass this variable tokens to this function right there. And then in x, it should give me the length. It should give me 1050 there. Let me try that. I'm actually going to run that whole thing right there. And then now that x now represents 1050. So that size has been thrown into a variable 1050 there. Now, let me do this. I'm going to walk you through this to show you what happens in a function. And if you've done programming elsewhere in Spider, the way to debug is you find a place and you set clear, or you set a breakpoint, okay? And then I can run this program up to this point and then step through, as they say. So the way I do that is that I select that one right there, that blue with the 2 lines next to it, and that'll start the debugging for me. And then I hit this guy right there, and it'll run all the way up to here, okay? And I should be able to now step through it. So, oops. Let me start it again. Good. So now what I've got going on here is that if you can see this blue line, it's now taking this tokens here, and it's going essentially to this line here where the count words are. So, and now that I'm in here, you can see that it's taken this word tokens and it's passed it in. So I'm able to access it here in, let's see if I can get that. And it basically is passed in that list all the way, okay? And then what it's going to do is it's going to do something called a return, and return means report back whatever this calculation is right here. And so I can continue to work over that, and I'll be back. And now I've got X having that value. Or so what? That may seem like a waste of time. Well, let's look at this. Up here, we've got this function called type token, and it's going to take in that variable, tokens ls, okay? And it's going to give me what are the unique items in there versus, and then calculate for me what the total items are. And then it's going to return to me the division of those, okay? And so now, instead of, I can compartmentalize my programming and just create this function here that I can use over and over again, okay? And it'll report back to me into this variable TTR. So let me just run that. And now TTR has in there that 0.4352. All right, so then what have we accomplished here? So, you know, we can break up our text into different lists, one with the tokens in it, another with all the tags in it. And we can also create these reusable little pieces of code that are going to become very useful as this all starts to move a little bit faster. Okay, so I'm going to move into number 6 here, file number 6 in our list. And I will again start this up. I will remove all the variables just to start clean again. And what I've done here is my Python file begins with this import statement. I've got a couple of these functions that I moved up to the top, and that's what I like to do is at the very beginning of a file, put in all my little functions I like to use. And then we're going to come back to this one right here, okay? And we're counting tags by prefix, all right? So I will, let's see here, how far, okay, good, yes. As a matter of fact, all this here is everything we were working with in file number 5. As you can see, it gives me all that data back, okay? Good. And I've got my tokens here. I've got all my tags in this other one. Great. So now, if you notice here, I've got this function, okay? And this function basically takes all my tags, and it's going to tell me how many tags begin with N, meaning how many tags are probably nouns, how many tags are verbs, how many tags are conjunctions. And as you can see, by creating this function, I've got the same syntax for everything, except that I'm changing around this second variable that I'm passing to it, okay? And it's going to produce for me the count of that. I'll go up to this. Well, let me just run the whole thing for you. And now, for this particular file, I'm able to count the number of nouns. There's 330. There are 189 verbs, pronouns. That was calculated down here. 93, and then conjunctions, 34. How did that happen? Let's go up to this count tag by prefix, okay? And what this does is that, if you remember, like I passed in here, maybe an N, okay? So I'll just put that there for you, all right? And I'm doing list comprehension here again, okay? What I'm doing is that I'm looping through tags here, okay? And I'm saying, okay, just on these 2 lines here, just loop through the tags very quickly, okay, each of them, and let's have a look at them. And each one we're going to call I, right? So we're going to loop through those. We're going to call them I, okay? And then give it back to me, please, okay, if that I And this is one of the great things about Python with text processing. It's got all these real easy ways of looking at text, okay? So here, this I, it's saying, and actually, let me do a little bit, slow down here, okay? And what I'll do is, let me take this one right here, and I'll do NNN, or NNS, okay? And then I can add to that this starts with, okay? And I can put K, for instance, okay? And so it's gonna tell me whether it starts with K or not. And it's got faults there, so it doesn't start with K, okay? So I can do it again, and I can check to see whether it starts with N. And yes, it does, okay? But I can do it with another one, and no, it doesn't. So if this prefix here, right, which you can see down here, I'm checking against it after my for loop, begins with N when I pass in N, and that happens on this line right here, right? It says go into that function, let it look at all the tags, but check to see whether the tag starts with N, okay? Then it gives it back and it puts it into this new variable I'm calling matches, okay, that match that criterion. And then send me the length back, okay? So this function here will take any list, okay, and it'll take any prefix. That's the great thing about it. And you can reuse it over and over and over again, okay, in one set of operations here, okay? And then it'll send you back the length of that. So when I did that for nouns, it told me how many began with an N, with a V, oops, with a V, with a C, because those are conjunctions, and then pronouns. And so now I've got this list here that I can, these numbers here that I can work with. Oh, and by the way, also I can get my type token ratios, and it's all on one line there. All right. Let's see here. Good. Okay. All right. So now we're moving along. Just to recapitulate here, or just to sort of summarize again, in my Python file, I've got my importers at the very beginning here. And sometimes I like to write them like this, because they really are just, you can call them functions all you want, but basically they just help us, okay? It's like we're doing the same thing. And then maybe just sort of organize it like that, separate it out, because you want to be able to read this a year from now. Remembering that you read code more than you write it, okay? And so, you know, you have a nice descriptor of your function, okay? Count tag by prefix. I don't know. I mean, any linguist could look at that and say, well, you must be counting tags by prefix there then. Yeah, absolutely. So don't make it something, you know, obscure, like CTP or something like that, okay? Anyway, so I'm going to move on now to number 7. I like to clear it out, okay? And let's do, yeah, let's add another function here. And we're moving very quickly now. We're getting close to moving to the part where we're going to be working with multiple files, which is probably what a lot of you are hoping we can get onto sooner than later. So we can do really powerful things with this. Look at this one here. As many of you guys have probably done research on, you know, corpus research, you know that type token ratio is really not very useful after a certain number of words in a text, according to, and I can tell you myself too from my own experience, is that, you know, really, if you're going to do type token ratios, there's a lot of different ways to handle it. One way, and I'm sure that the wordsmith people are going to talk quite a bit about this. One way is to simply do your type token ratio on the first n number of words in a file, you know, so like the first 500 or the first 1,000 or something like that, because people tend to repeat themselves. And that's true from a cognitive perspective. People tend to prime themselves. If you take a course on second language acquisition, and actually interlocutors do as well. So why is that important? Because people tend to use most of the new words they're going to use within a certain window of when they start writing and or speaking. So, okay, leaving that aside, I know none of you came here to learn corpus linguistics from me, okay, but we can figure out a way of respecting that notion and saying, I want to get the type token ratio, okay, looking only at the first n words, okay, and I want to write this in a way such that I can control and I can experiment around with what's a good window to look at, is it the first 1,000 or whatever, okay? So what I'm going to do is I'm going to show you something here, a technique, and let me see, I think I have it here for you. Okay. Oh yeah, good, here we go. So let's take this. Let me clear that out so you can see that. Now I create a new list, just those numbers right there, okay? And Python has some amazing ways of just splitting up these arrays, these lists, okay? So one thing I can do is that I can tell this, I can create a new list by just returning the first 3 variables of that. So you can imagine that if I had, for instance, a list of words here, okay, then I could say, well, give me the first 1,000 words. And so how does Python do that? Well, very simple. You take your variable and you put brackets around it, okay, or you put some brackets next to it, okay, and instead of grabbing like one of them, which is all that would do, is that you could put a colon here after that, and you can say, start with 0 and give me 3 more of these. So if I do that, then that'll give me the first 3 items of that list, okay? So for instance, Python has this thing where you can create a list of numbers, okay? Let me do this. So I'm putting in the second list, this huge list of numbers, all right? And then I want actually the first 400 of those, okay? So then I could say first 400 equals ls2 0 to 400, all right? And now that's going to give me the first 400 of those, okay? And so the bottom one here should be 399 if my math is correct. Yeah, exactly. So you can imagine then we could do this same operation in doing a type token ratio. And what we've done here, I'll go back to the file now. And what we've got then is it says, okay, same idea, give me all my tokens. Go back over here. Give me all my tokens, okay? But instead of doing the type token ratio on all the tokens, let's do it on the first whatever number you, the programmer, gives me, okay? And where is that happening? Just right here. It's taking my tokens here. I'll go back and put this right here, right? It's taking my tokens, okay? And then it's saying, give me from 0 to n. And then if you put in, when you do this, you put in 1,000, then it's going to give it on the first 1,000 of those, okay? So it's basically chopping this tokens list off at 400 or 1,000, I'm sorry, or whatever n you give me here. And then it does the same calculation, see? It's got the same sort of logic as you have over here, okay? So what we've got going on here then is I can get the type token ratio on this, and I want to get it on the first 100. Okay, and I'm going to bump it up to 200. And let me run it. And then now I've got all my data. Oops, I've got all my data here. And now my type token ratio is 0.64. As a matter of fact, that's something I've learned about these windows of type token ratios. They tend to be really higher numbers. You have a lot more diversity, basically, what you have. So at any rate, what's the purpose of number 7 here is to show you that we can create some really powerful functions to make our code modular. And if you see this here, this is just getting the numbers and throwing them into variables. All right, now we're going to move a little bit faster. Good. So one thing I want to talk to you about are dictionaries. Okay, so dictionary then is basically, let me clear this out. Looks like this. And a dictionary is a structure that holds variables, okay, in one package. And we'll see that becomes really important when we want to take all of the calculations for one file and then throw them into sort of like a spreadsheet that we can work with later, so we can keep the information organized. And it's called a dictionary because you have these things that are called keys, and the keys are basically the lookup element in a dictionary, and then it's got values. And these values don't have to just be single numbers. They can be lists themselves. They can be as complicated as you can imagine, okay? So what I'm doing here is that I'm defining it by saying, okay, I want the word the to be 5, I want the word to be 9, and I want the word some to be 4. Maybe these are counts. Okay, so what happens here is that I've got this dictionary, all right, and it's got these values in here, as you can see, okay, and how can I access them? Well, same idea with the list is that you use brackets, but then what you do is you call on the key and it'll tell you, oh, my bad, sorry about that. You call on the key and it'll tell you what, in the dictionary, what the value of A is, okay, or is, and it should give you back 9, okay? And you can do all sorts of things with these. If you want to like add them together, all sorts of things, okay? It's just, the sky's the limit, okay? We could even find out what the proportion of A and the are. Oops, I'm sorry. Yeah, I think I can sum those up. Yeah. Oh no. Well, I'll show you how we're going to use them here. Let's see here. Okay. So what we're going to do here, what we've done here is that let me run all this code here. And we'll clear that out. Got my data. Okay. And now I've got this dictionary here. And instead of throwing these into individual variables, I'm going to throw them into this. I declare this dictionary, okay, put nothing in it, right? As you can see that over here, I could have done the same thing. I create a new dictionary. And now it's empty, okay? But I can add a new one to it by doing this. Okay. Nouns, for instance, okay. And then maybe I would, you know, come with some calculation and say, okay, nouns is going to be equal to 89. And then if I wanted to add in verbs, maybe it was 56. And now this dictionary is storing all my data for me. And I'm going to be able to use that much more easily. Okay, so I'll come back to this right here, and then I'll run this. And now my dictionary is starting to collect all my data for this particular this one file. And as you can imagine, when we move on to the next chapter here, 02, we're going to be able to do this for each and every file that's in there, and then eventually throw it into a spreadsheet for analysis. So what does this do down here? What this does is that it takes all these data, it takes this dictionary here, okay, and it throws it into a CSV file for me, okay. So let me see here. I can select that now, okay, and then it's going to write into there D, okay. It's going to throw it into a file for me. So I just put this in here so that you could, you know, you have something to sort of play around with, and you can sort of look at the anatomy of that. It basically opens up a file named tabs CSV, and then it writes it into that that file. And I should point out that it has a particular module, so you do have to import it. So import CSV. So always look at the top of these files to find out what I'm importing if something goes wrong. And I should be able to run this. There it is. And so then here this is, and that's my CSV file. And it's written it out for me. Not very useful, you know, at this point, but you can see the idea of where we're moving. Okay, so we're still working with one file. I'm going to clear this out. All the variables. Okay. And now I'm on to number 9 here. Okay. And I will, oh yes. I want to do this. Run this one here. And now you've noticed that I've imported this module from the NLTK library called n-grams, and that's what it gives you, is n-grams, okay? So what it does is this portion right here, okay, is that if I were to, let's see here, let me separate this out for you, okay? If I were to run this n-grams item, it's n-grams function, okay, which comes from the NLTK toolkit, okay, I throw in tokens ls, and that's this right here, okay. What this module does is it's going to give me every single n-gram, every single, and I've got 2 there, so it's going to give me bigrams. So it's going to give me learn politics, politics y, you drive, etc., etc., etc. Okay, so let's see if that works. I'm going to do it like this. And see if I can. Okay, so what that does is it gives me something called a generator. And this generator basically is saying this, is that I'm ready to run over and give to you all of these bigrams that I've found in this particular text, okay? And so it doesn't readily give it to you in a list. And the idea here is, without going into too many details, is this generator is actually a very memory efficient way of handling all these tokens. As I said at the beginning of the seminar, working with text can actually, as you accumulate words, can actually slow down your processing quite a bit. But for our sake, or your memory, it can occupy a lot of memory, let's put it that way. But what I'm going to do is that I'm going to take this and I'm going to, and they actually call it in programming coerce. I love that word. I'm going to coerce it into a list. So now it's giving me every single bigram in this text, okay? So I didn't have to write any code. The Natural Language Toolkit did this for me, right? Learn as a girl, Girl Scout, Scout leader, etc., etc. Okay, so that's what I've done over here is I've created this variable. I put into a list. Okay. And then what I'm going to do is, now that I've got this bigrams list, okay, so where is that? Ah, there it is. That doesn't help me too much. I want to get at learn space politics, and then politics space while, and while space u, so that I can sort of calculate what are the most popular bigrams in this file. So how do I do that? We've learned all the concepts up to this point. What I can do is I can iterate over those bigrams, okay? That bigram list that I just created, okay? Actually, I'll bring that up to put it side to side. And I can iterate over it, okay? I for bigrams, so I'm gonna go over each one of these. And what I'm gonna give back is, I'm gonna give them all back in this new bigrams list. But I'm gonna take the first one, I of 0, and then I'm gonna add a space to it, and I'm gonna add I of 1. And that's gonna give me a string of all the bigrams in there. So let me run that. And now my bigrams are gonna look like this. Great, I've got that right there. All my bigrams. And now I got one other thing that the natural language toolkit can do for me, okay, is that it can actually calculate on those bigrams there a frequency distribution, okay? And it can give me the most common, whatever number I want it to give me back. So let's say I want back the most common 100, okay, of those bigrams in this particular text. And I can run this. Okay. And then if I go look at that bigrams there, it's telling me I've got, okay, prepare 2 is the most common, to win is 7, it be is 6, etc., etc. And then if you want to look at that in a CSV file, you can play that, you can run that part of it. As you can see in here, I've got in a CSV file all the bigrams. Yes, someone asked me if I'm searching for trigrams through the code. Absolutely. Let's see here, what else? So Joe, if you don't have the someone's asking me if you don't have to define prefix, it's enough just to specify the position, the code. Absolutely, you can do that, Tove. Absolutely, you can do that. You can also get a lot better results if you use regular expressions, and we can maybe do that in a follow-up seminar. I'd be happy to do that, because that's one of my favorite things to do, is to work with regular expressions. So let me see here, go to Denise's question, is that, yeah, if I wanted to get trigrams, I can change this guy right there, right? Okay. Now, oops, well, why don't I just do this? Make my life, make all of our lives easier. Someone asked me, I should make sure, someone asked me how I could do trigrams. Piece of cake. I'll copy this. And then I'll change it here, right? TRI, and I can even get those right there. So I didn't practice this, so if this doesn't go right, oh yeah, I can see where I might do. So I'm going to get my trigrams here. Okay, I'll run that part of it, and bets give me trigrams. Beautiful. And I'm going to change this up, right? But now I'm going to want to do 3 spots. I changed this because I want to iterate over trigrams that I started up here, right? Okay. And then, oops, I need to put a space there, don't I? There we go. And then I should get trigrams. Yeah, that's good. Learn politics while you drive if, da, da, da. Good, looks good. And then let's get our frequency distribution. But you can probably see an error here, right? Is that this is going to be working with that variable, the bigrams. I need it to work with trigrams. Oops. The most. So I'll run that. Come back over here. And we've got our trigrams frequency distribution. Prepare to win is the most, and then was a precipitous drop off after that, right? Good. So, and then if I wanted to write this out, obviously, change the name there. Trigrams. Let's make sure that I'm doing that. And then I should have a file here with my trigrams. There you go. And that could be useful, you know, if you're doing a bunch of files. We can get better though. Let's see if there's any other questions. Okay. Whoops, make sure I didn't miss anyone. Okay, good. All right. So that's the first chapter. Okay. Now we can really start moving. And what I want to do is in this next part, we'll be able to iterate over a whole bunch of files, create a dictionary for each file, and then throw it into some way that we can use that in a spreadsheet situation, okay? So, and then eventually you could throw it into R or into SPSS, okay? So what I'm gonna do is, we'll close all these up. And so what I'm going to do is I'm going to change up here the working folder because so now I want to be working with these files in here, okay? And I want to explain something to you of the way that I like to do my workflow is that if I'm working on a complicated sort of process here, and again, I want to read this a year from now. Okay. I tend to break my processes up into individual files, store data in a folder, and then maybe in file number 2, I'll go back and maybe draw on the data in folder number 1, you know, the results there, and then maybe store that in folder number 2. So there's this process of creating more and more complicated calculations, but also I can go back and understand it later and actually make modifications because let's say I screwed up something at point number 2 here in producing this data in folder number 2. Well, then if I've done 3, 4, and 5, and this actually happened with working with 𝗂𝗄𝗄𝗏, is that when we were working together on some calculations that we found, we screwed up on a step here. And so it wasn't that big of a deal. We could just go back and make a change in one of the files and then just recalculate down, okay? So that's why I have this organization and I encourage you to sort of do the same thing. All right, so what are we gonna do here? My headers here, I've got my NLTK and some helpers here for you. I want to import CSV to be able to do that. And then there's this library here called 𝗏𝗏, okay? And 𝗏𝗏 is a curious name, but basically it lets you work with the files in a folder in a very efficient manner. And if you've sort of used in other programming situations, wildcards, what it does is the following, is that it says, let's go through this folder here, so 𝗏𝗵𝗄 𝗏𝗏, so it's going to be this one over here, all right? It's got a bunch of files in there, 20 of them, okay, to save time. And it's going to say, okay, let's work with just the files in that subfolder 𝗏𝗏 that end with the suffix txt, that are txt files. So if you have some other stuff in there, like a README file or something like that, it's going to ignore that file in there, all right? So it's going to iterate over every single one of those files, all right? And then it's going to do a couple of things here. So I need to sort of slow down here for you. Now, the reason why I gave you this helpers file, all right, is that in there, what my helpers file does for you is that it lets you take that file that you get back from this glob process, all right? So it's going to go over every single one of these right there, and it lets you get some file information on it, and then you can break it down into the file name and then the file path, all right? So the file name will end up being 1.txt and then 2.txt, but also in case you need to do some accounting later on, or you want to record for each file what the path was, so that when you go back and look at this data a couple of years from now, you can say, oh, crime, that's where those files are, because that happens to me all the time. Data looks good, but I don't remember where the corpus is. Then you can record that if you want to, okay? So that's going to store in that variable. Okay, it's going to store in that variable the folder path. Good. What's happening here? Nothing new. All this we've been doing all along, guys, is that I've got my text here. It's going to open it up. It's going to filter out the header lines. I'm going to tokenize it, get rid of the punctuation. I'm going to put into one list all the tokens, another list all the tags. But now what it's doing is it's doing it for every single file, okay? So it's going to, what I'm doing here is I'm creating a dictionary to hold all the data. And then for this simple analysis, guys, what I'm doing is that I'm going to store in file name, all right? The name of the file. I'm going to get the word count. And the word count, again, comes from this little function up here we worked with. And then I'm also going to get the type token ratio. Okay. And so I'm going to calculate that there. And then what I'm going to do is I'm going to add it to the end of this new list, okay, that I'm going to create, that I've defined up here, all right? And then I'm going to write it out to a file. So now let me back up on this type token ratio. And here's the big lesson that I've learned and worked with other people and myself on making calculations across a number of a corpus, let's put it this way, a whole bunch of files, is that things can go wrong, okay? So for instance, you can imagine, like one thing that I've come up with is that sometimes I come across a file that doesn't have anything in it. I don't know how it actually made it past the process, but it has actually 0 characters in it, okay? So expect the worst, all right? So what I've done here then is on this type token function right here is that I've said, okay, let's do this. Let's try to calculate the type token ratio, just as we did before. But if something goes wrong, okay, then, and that's what this try and accept sort of syntax does. It says, okay, we'll give it a try, see if you can get the type token ratio, but if not, don't stop the whole computer, okay? If you can calculate the type token ratio, everything goes well. So for instance, the total number of words doesn't end up being 0, right? Because if this were 0, and you didn't say, well, maybe, maybe it had nothing in it, okay, then it may very well be the case that Python tries to calculate that using 0 as a denominator, and of course it says, whoops, can't move any farther, you can't divide by 0. What this does is it says, look, if you can't divide by 0, if something goes wrong, okay, then, and this is just my preference, Joe Collentine's, is that I like to give numbers, I like to assign it a value that I can filter through when I'm done doing the analysis. So I know that there's no type token ratio that's less than 0, so I give it a -99 or a -9999 or whatever, okay? So what this is going to do is it's going to store in folder 01, okay, the counts for all these files. So let me run this. And you can see over here, after I run this, this 01 folder is going to have the results. Okay. And so it produced it. And that's becoming more useful, not entirely, but it's becoming more useful because, you know, now it's got for this whole mini corpus, I've got the name of the file, its corresponding number of words, and the type token ratio. Okay, and you can see that there's a variation of them. Now we're moving in a good direction, and we've got safety measures as well. We're organizing our data by doing dictionaries for each of the files, okay? And we're able to store the dictionary. That's what this was about, although this is not what we're gonna end up doing. But we're able to store a similar object type, okay, for each file. And then we can, you know, you can imagine if you just wanted to quit listening today, right now, you corpus linguists out there could probably finesse this into something that was manageable, right? By, you know, getting rid of all the file names, all the word counts, and then putting tabs there or whatever. But we can do better. And it's doing it for each file. And then I'm writing the results here to 01. Okay, good. Question. 𝗬𝗖 and I'll stop for a second. 𝗬𝗖 and LTK. I've tried to use 𝗬𝗖, and it's really good. It's a competitor to NLTK. The question was, can you talk about the difference between 𝗬𝗖 and NLTK? NLTK has a lot more, I would say, a longer period of development. I know that 𝗬𝗖 came around a couple of years ago. I tried to use 𝗬𝗖 a couple of times, but there were just some quirks, especially for what I want to do, because I'm always working with Spanish corpora for the most part, and you know, lately with some Portuguese corpora. So I found some problems with non-English. Duration seminar goes till 12. So that was from Denise. Yes. So I hope that answers your question. But 𝗬𝗖 is an interesting alternative. Okay, now let's move on to number 2. With number 2 now, I've introduced a new module here called pandas. Okay, and pandas is basically a way of efficiently replacing into an object in Python that is Excel-like, meaning it's spreadsheet-like, because the idea, it actually uses what's called a data frame, and any of you guys who work with R know that that's the main object of R. But my reading of pandas is it's basically uses the word data frame in the way that most of us are using spreadsheets, although it easily integrates with R and its data frames, okay? So how does pandas work? Let me do this, okay? And I'm going to, all this will make sense if I give you a slower presentation. We'll be able to make a lot more progress if I do this for you. I'm going to, okay. And what I've done is I've imported pandas here, and then I've created what's called a data frame. Data frame is basically a spreadsheet, okay? And what it does is it uses that library, creates this data frame, and then what I do is that I tell, okay, create a data frame with these columns, right? There's the spreadsheet sort of metaphor. File name, word count, and type token ratio, right? What we were doing before. So now it's empty, as you can see. It's got 3 columns, no rows. You can look at it. It's got no data in there whatsoever, okay? So taking this a little bit slower, how do we add data to it? Well, this is why I encouraged you to put information for each file into a dictionary. Let's say we've got that data point right there, okay? For file number 1, the word count is 40 and the type token ratio is 35, okay? Question is, how do we get that data into this data frame, okay? this virtual spreadsheet. Very simple. I basically copied this into text file so we can save time. Is that I'm going to do the following. And there's some weird things I still don't like about it, but it's really a great library. Is that it says take that data frame there, okay, and append to the end of it this variable D, okay. And what it does is it says match up file name to file name, word count to word count, TTR to TTR, and you got to add this in, okay. If you're working with dictionaries, if you don't, you'll get an error. All right, so you just got to believe me on this part. So just use it. And then what you got to do is that you got to pass it back to itself, meaning make it equal to itself. Why they did that, I have no idea, but I have an idea, but basically we can add to that data frame. And now notice up here in the size, okay, is that now it's got one row. Well, we can go through another file, right? And I've just sort of conceptually for you here. I added another row to it, new dictionary, right? This is our new iteration through the file. It's number 2, 43.39, and then I did use the same syntax to add it to the data frame. As you can see now, it's got 2. If I double click on it, can you see that you've got then a file name, word count, and the type token ratio different for all these files? And you can imagine then we could have 1,000 of these. All right, I'll do one more, like this. And I want to demonstrate one more for you. Now you can see this got 3, right? It's got 3 of them. And here's another great thing about this pandas, is that I can take that data frame and then I can put it into a CSV file, okay? And it'll store it. It should store it in, oops, I gotta make sure that my working directory is the right one. It should store it in number 2 here if I do this. And so it basically says, take the data frame, put it in a CSV file, call it that, okay? And then you gotta trust me on this one, folks, is the index has to be equal to false. Otherwise you'll get like that, you'll get that index on the side. If you want it, you can have it, but I tend not to need it. So let me see here, yeah. So then it created a CSV file for me of that data. Now that right there, if some of you guys work with R or even SPSS, you know that you could readily import that into R or SPSS or any stats package and work with it. So here, so you're copying and pasting this whole thing. Yeah. Elisa, I am copying and pasting it in. I'm saving you guys the time of my slow typing abilities, because I'm 58 years old and I've only made it up to 3 fingers so far, but I'm really fast with those 3 fingers. But I didn't want to torture you guys with like me. Yeah, well, you're probably up to 5 though, so you're my hero. All right, so at any rate, so you guys can see where we're moving along a little bit faster now here, okay? And what I'm going to do is, okay, so I'll do the anatomy of this for you here, right? We've created the pandas data frame right there. I'm telling it, here are the the column names, okay? Got my type token ratio. My type token ratio calculation that's safe, okay, that if something goes wrong, then it's just going to give me a -99, and that's going to be up to me to clean up that file. It's going to iterate over the whole corpus, this mini corpus we've got, okay, which is right here. I've got it right there, all right. And actually, what's my corpus here? How many I got there? Oh, I've got a bunch. Well, let's be bold and use the corpus instead. All right, yeah, we'll do that. And then this might take a little while longer, but it's still pretty fast. It's going to put in the data for each file in the dictionary. I'm sorry if I'm being redundant, okay? And then I'm going to accumulate into that data frame, okay, the data for that particular file using those processes there, okay? And then at the end, it's going to put into folder 02 into a file called data2, and that's CSV. So let's see, running it, it's done. So that was 151 files. That's pretty fast. Questions? Okay, no. All right. I'll put that off to the side. Maybe I can see that. Okay, guys. We are moving faster now. And what do I want to do here is I wanted to oh, okay, yes, I know what I was doing here. On this one, let's look at the very bottom here. Okay, and no, I think it's the same one. I'm sorry, folks. I think it does the same thing. Yeah, I think this time I was going to run it with the whole, yeah, that I was going to do the whole thing. So I anticipated this one. Never mind. Forget about number 3. We'll do number 4. Ah, yes. Okay. This little segment here might be helpful for you. Is that let's go and do that subcorpus, which has got 151 files. Okay. When you're checking out your logic of your computer of your Python program, I like to be able to sort of run it on random on random items in the folder. So what this has done is it notice I've got I create this file list here, and then what I'm going to do is eventually iterate over that file list. Okay. And what this does is it uses this library called random. And what it does is it takes that file list. Okay. And I think I can actually show you this. All right. Let me run it up to here. This thought it was a question. I'll get that question in a second. Yeah. So I'm going to run this really quick for you. And you could also use this technique for sampling. You know, so if you want to run a factor analysis on half of your data set, and then also have a verification data set, you could use the same process, right? So at any rate, what this does is it gives me this list of files, all 150 of them. What I want to do is I want to grab a random sample of those, and then run my analysis just to see if whether I'm doing something wrong, rather than having 1,000 files or 25 variables and wait all afternoon and find out that it crashed or I've done something really stupid. So what this does is now it takes this file list right here and it will, it'll randomize it for me. Okay. So now you can see that the list is going to do a random list. And then think about it. Now I can take the top 10 of those of the other operation, and then I can run this analysis over just 10 of them, and then do that over and over and over again. So let me do this. I can all right, I don't see anything wrong with those numbers, but I'll do it again now because I've got this whole part selected here, and I can look at the data frame again. And yep, and that's a different sample, I think. Let me see, it started out with 37. Yeah, it's giving me different ones every time. So that's good. Now I feel comfortable with this, all right? So then that's just one way of doing quality control. Now, I've got a question here from Elisa, who says, what to do in order to order the columns, say, by alphabetical order. There is a way to do that. What you have to do is, I won't show it to you right here, but here's the logic. the logic is that you basically have to get a list of the columns again. So you put that into a list originally, put that into a list of the columns, okay? And I'm making it actually more complicated than I need to. When you define this right here, I'm sorry, I should say, this is where you would get your alphabetical order, okay? You would make sure, so for instance, that the first one is your file name, right? Something that you can read as a unique item there, okay? And then you would just make sure that the presentation of the variables here are in the order that you wanted it to. So if you wanted it in alphabetical order, then before you do this, you would do that. But it is actually a really good question. I could do TTR there, but look at this. I could do the calculation here however I want. I mean, if I thought, oh yeah, I want a calculation for nouns or whatever, okay. I could actually, yeah, I could add that. Say I wanted to add, I did nouns here, okay. And do I have my thing? Oh, I don't have that function here. Well, then I won't bore you with that, okay. But anyway, I could calculate it down here in any order you want, but I would set the presentation here in the right order. I think that answers your question, Lisa. Okay, good. All right. So let's see here. All right, good. Now, before I do number 5 here, and we're running out of time, is that here's the deal. How to get this data file, right, into something that's useful. Now, I'm going to open up number 501 now, okay? And yeah. Good. This part here is I'm going to look at folder number 5 there, okay? And I'm going to run that. As you can see that I've got this dictionary, and now I'm going to run a whole bunch of different calculations. And that's using all these helper functions that we were using before, right? Type token ratio, the type token first n, maybe I'll use that, or I'll count the tags by prefixes. And then here, right, I have my list of variables here, okay, and then I can control for this order as you were asking there, okay, and I can run the whole darn thing, and then I'll get a new data file at the end here. That's done. Here's my data file. So it's got word count, type token ratio. Oh yeah, I did one for the first 100 words as well, and then nouns and verbs and pronouns, etc., etc. Okay, I'll go back to number 2 here. Now, this is a different file here, okay? And this is showing one more thing that would be useful for the heavy hitters out there. So that's a baseball term, I'm sorry. Is the people that like doing real heavy duty statistical analysis. There's a bunch of libraries. One is called SciPy, so this is science for Python, and it's got stats in there. And let's say I wanted to run the z-score or normalize, right? The one particular field, okay, one particular column, I'm sorry, okay? So here's the reason why Carol and I came up with this sort of plan of saying, okay, well, I'm gonna put into one file all my data, and then I'm going to read it in again, okay, some other point, and do some other analyses on those, all right? So in this particular file here, 502, I'm reading in this file here, data, okay? And then what I'm going to do is I'm going to read it in as df. Let me show you this real quick. Oops. Remove all the variables. So I'm going to read it in. I'm going to read in that z-score function as well. Okay, so I've got my data file, data frame, I'm sorry. And what I want to do is, oh yes, I want to create z-scores, okay, for all of these columns right there, but I don't want it for file name. So what I do then is that I create a new data frame by grabbing a subportion of that data frame. And what this syntax does is says, okay, with that data frame there, you put into a list all the variables that you want. Okay. So then this sub data frame syntax. So you've got brackets inside of brackets. What that does is it gives me that right there. Okay. And now I've got this new data frame. Okay, with just my numerical columns, all right? And then what this does is it uses this function called apply, and what it does is, someone's asked about lambda functions, what it does is it says, okay, this is how you read it. If it goes through each of the columns, okay, it applies some function to each of the columns. The function is on this line. It says, for each column, go through and give me the z-score for each of the values in that column. Okay, so that's the lambda function right there. And it says, do it if for, what I'm going to do is, I know that my sub data frame are these guys right here. Okay, but I only want to do it for word count, nouns, yeah, verbs, conjunctions, and pronouns. I don't want to do it for any of the type token ratio scores. I'm not gonna normalize those. Okay, and so it'll say if the name is in this particular list, then do this calculation here. Give me the z-score for it. Otherwise, just give me the column back. So we'll do that. And now this better one, as you can see, is giving me, yep, this word count as a z-score, okay, and all these guys over here as a z-score. And then I can put that to a file. And that's it, right there. So I've got that. See if there's a question. It's there. Oh, this, okay. Good. Let me answer these questions in order. So a data frame is like a matrix of values. That's exactly right. Yes. And it gets imported into R, for instance, as a matrix or as a data frame as well. But it's basically columns where you have your variables, your independent variables, right? And then your cases in each of the rows is exactly like a spreadsheet. And that's why in pandas, I'm sorry, that's why in pandas and in Python, when you look at it, you know, it basically looks like how you would look at it as a spreadsheet. What does the 0.5 mean? Ah, okay. So the 0.5 in here means, this basically says that what I like to do is I like to match the name of the file I'm working with. So this is step 5, and then I like to match it to a folder here. And so the output of file 0501 is going to go into folder number 5, because I may want to do something with that at some later point. So it really is just, and this came up, let me just talk a second about this. This came up where I was working with someone and the person had really good code, but it was trying to accomplish everything in one program. I've never seen that work. You've got to break it down into different steps, and that's all that this is doing. Let me see here if I can, I don't think, oh yeah. So this one, number 3, okay, 503, what it does is, oh, sure. It uses this library. So SciStats, SciPy stats is a z-score, and then it imports this other one called NumPy, which is a number, which is a way of working with numbers very efficiently. Okay, and what I've done in this particular one is that, oh, I said for my data frame here, I've said for in this apply function, for word count and nouns, I want the z-score. Okay, But for verbs, conjunctions, and pronouns, like maybe I was looking at that data and I found that it really doesn't lend itself for use in some statistical analyses. Doesn't meet the assumptions of normalization. So I said, well, then I need the log. I'm gonna have to convert those over to logs. Okay, and so what that does is then it takes, and I'll let me clear this out so we can look at it being built little by little. Got our data frame. This is the last step. Got our data frame there, right? Okay, so there's our data, just as it was brought in from the file. Now I'm going to turn word count and nouns into their z-scores. So now the word counts, yep, those are z-scores. And the nouns are as well, but everything else is left alone. And then somehow in screening my data, I figured out that verbs, conjunctions, and pronouns need to be in the log format in order to meet the assumptions of a normal distribution. So I can do that. And again, if you're playing around with this, as long as you organize your data the same way that I have, you can experiment with these later on and substitute whatever you want. And then now I should have verbs, conjunctions, and pronouns in. Yeah. And what's cool about this, as far as I'm concerned, is that it seems that, and I have to test this out a little bit more, it seems that the NumPy analysis of the log 10 takes into account if you have values that are 0. I think what it does, I could be wrong, but I think what it does is if you have values of 0, it then, as you guys, if you've ever worked with a transformation, it'll shift it over by a number of 1 or something like that, so that you can get a log 10 distribution. Because as you know, the log of 0 is undefined. So, and negative numbers as well. So it seems to do the math for you. You don't have to create your own function. And I really like that, okay? And then one last thing, this is my gift for you, is inside this helpers function, there is, in this helper file, I'm sorry, okay? Now that you understand functions, okay, then what it does is it will use that data frame apply process that we're looking at in the five files, okay? And then I've created this little function for you that if you wanted to replace text, because it's not as it's easy with this apply function with data frames to use numerical transformations, but if you wanted to, for instance, replace some text or modify the text, then I wrote this little thing for you and you can use that yourself, okay? If you don't want to import it from the files, from the helper files, you can just copy it and put it at the top here and use it that way as well, okay? And then it'll run it. And what it basically does is it takes every single column here. Let me say you said, oh, I don't need that txt there. Or if you want to do some string operation on it, change it some way, okay? Cut it off, get the prefixes, get the suffixes, segment it, then you could do that as well. And that's all that does right there. So I'll run this and show you what the result is. It's going to be in number 3 here. Should be right there. Yeah. So then, what it gave me was all these data points here, right? Okay. And then it gave me the file name without the txt there. Actually, it probably looks better. Yeah. Like that. So now, last thing then, since we're basically out of time, is that, again, and you guys have done statistical analysis with SPSS or R, you can see that this file format here will readily go into an R or an SPSS analysis very simply. And there are ways to, we can talk about maybe later on in some other course on how to get those down to, you could actually bring this into, if you thought that, these need to be rounded, then you could bring this into Excel and then just round it that and resave it out.